Imagine this. Every single person on Earth, all 8 billion of us gathered in one gigantic sprawling crowd. Picture the sheer magnitude of humanity shoulder to shoulder, filling every available space. We count down the seconds, a shared anticipation crackling in the air. The energy is palpable, a collective breath held in unison. Then on cue, every human leaps, a planet-wide synchronized jump. The ground momentarily loses contact with billions of feet. What happens next? Does the Earth shudder? Do buildings crumble? Or is the impact as underwhelming as a pebble dropped into the ocean? The possibilities are endless and intriguing. This quirky thought experiment, a staple of internet forums and curious minds, seems to touch on a primal fascination with our place in the grand scheme of things. It makes us wonder about our collective power. Could we, a species that evolved from microscopic organisms, really generate enough force to noticeably impact a celestial body like Earth? The idea is both humbling and awe-inspiring. The answer, as it often is in science, is a fascinating blend of physics, myth-busting, and a dash of perspective. It reminds us of the delicate balance we share with our planet and the universe. Here's the thing about physics. It's all about scale. The universe operates on principles that often defy our everyday experiences. Earth, for all its beauty and wonder, is incredibly massive. It's a colossal sphere of rock, water, and life, spinning through the cosmos. Its mass dwarfs the combined weight of every human being by an astronomical degree. The sheer scale of Earth's mass is almost beyond comprehension. To put it into perspective, if you were to shrink Earth down to the size of a basketball, the collective weight of humanity wouldn't even register as a speck of dust. It's like comparing a grain of sand to a mountain. So when 8 billion people jump, even simultaneously, the impact on Earth's momentum is negligible. It's an almost laughable attempt to move something so vast. Imagine a fly landing on a speeding train. The train might experience a minuscule change in momentum, but it would be imperceptible to anything larger than another fly. The train continues its journey unaffected. Similarly, our synchronized jump would result in a minuscule shift in Earth's rotation, so small that it would be impossible to measure with even the most sensitive instruments. The Earth remains steadfast, a giant in the vastness of space. But what about the ground beneath our feet? Surely, a simultaneous jump by billions would send shockwaves rippling through the Earth's crust, right? Here too, the reality is less dramatic than our imaginations might conjure. While it's true that jumping does generate a tiny seismic wave, the magnitude is inconsequential. Think about it. Humans jump, walk, and run every day without causing widespread earthquakes. This is because the Earth's crust is remarkably good at absorbing and distributing energy. The minuscule seismic waves generated by our synchronized jump would dissipate quickly, likely going unnoticed by anything other than highly sensitive seismographs. Section 4. Mythbusters debunking the everyone jumps apocalypse. The internet is a breeding ground for outlandish hypotheticals, and the everyone jumps scenario is no exception. Some claim it could trigger earthquakes, shift Earth off its axis, or even cause the planet to veer off course. These claims, while entertaining, are entirely unfounded. Earthquakes are caused by the movement of tectonic plates, massive pieces of Earth's crust that grind against each other. The energy released during these movements dwarfs anything humans could generate by jumping. Similarly, shifting Earth's axis or altering its orbit would require an astronomical amount of energy, far beyond the capabilities of a synchronized hop, no matter how enthusiastic. Section 5. Reality check. The anti-climactic truth of a synchronized hop. So what's the final verdict? What happens when billions of people coordinate their efforts in a synchronized jump? If everyone on Earth jumped at the same time, the most noticeable effect would likely be the sound. A thunderous global thud as billions of feet reconnect with the ground. This sound would be heard around the world, a momentary echo of our collective action. Earth, however, would remain unfazed, its rotation and orbit unchanged, its crust unperturbed. The planet's immense mass and gravitational forces are far too great to be influenced by such a fleeting event. This thought experiment, while revealing little about our ability to affect the cosmos, serves as a valuable reminder. It underscores the limitations of human impact on a planetary scale. It highlights the immense scale of our planet, the incredible forces that govern its movements, and the humbling reality that some things, even when done in unison by billions, are simply too small to make a dent in the grand scheme of the universe. This realization can inspire a deeper appreciation for the natural world and our place within it.